derivative test. Yes?
Sure. Oh, look at that transition.
So let's review a little bit of what we did yesterday. So if I wanted to find where something is increasing and decreasing and find relative mins and maxes, what do we need to take? The derivative. So on this first one, what do we get?
X squared.
Okay. Then what am I doing with that derivative?
Setting it equal to 0.
Setting it equal to 0. So what do we get?
0.
Cool. So then what do I want to do with that?
Plug it into a number line.
Okay.
Sweet.
What am I plugging into the derivative?
Stuff around here.
Cool. So what's to the left of 0?
One, negative 1. Negative 1.
Okay. What's to the right of 0?
1.
Okay. So if I plug negative 1 back into my derivative, what do we get? Okay, so, but what do we care about? The value or the
Sign.
sign? So, what would 3 be?
Positive.
Positive. I plug 1 in, what do we get?
Positive.
Positive. So, what's that mean?
It's increasing
It's just
Where?
on both sides of 0.
So, where?
Left and right of 0. Negative
So, what's the
infinity
inner?
to negative 1
Oh.
union.
You should have just said that in the first place.
Or negative infinity, infinity.
Because you're not technically increasing, decreasing, or doing anything at a specific point, right? So, I don't have to exclude 0. So, it's
I guess
just
0
in.
can't be like negative 4 positive.
Yeah.
Because, like,
Now- So there are no mins or maxes because we do not change sign, but let's also think about what does my graph of a cubic function look like?
is it like a.
Down to the middle
Oh,
and
this
then up.
Right? It's like that thing. So we have a horizontal tangent at 0, okay, which is why we get a critical value, but we then continue to go up. So we don't change from increasing to decreasing, which means that we don't have a max or min there. Cool? Alright. On our next one, again, what do I want to do?
Derivative.
Okay? How do I take the derivative of this one?
1 over.
No.
Just kidding.
The quotient
Oh my gosh.
rule.
I was wondering why.
So I would have the bottom times the derivative of the top, which is
1.
minus the top times the derivative of the bottom, which is
1.
1.
Can we
All
factor out a 1?
over the denominator squared. We're not going to need to. So I have x plus 4 minus x. So what are we going to end up with on top?
4.
Okay. Now remind me, what are the two different spots that we can have critical points?
Undefined and 0.
Where it's undefined or where it equals 0. So if I have a fraction, when will it equal 0?
The top is
When the top is 0. Well, can my top be 0?
Probably not.
No.
Sorry,
Right? So 4 cannot equal 0. So I'm not going to have any spots where the whole fraction equals 0. However, could we have spots where it's undefined?
Absolutely.
Yeah. So notice that if I set our denominator equal to 0, we end up with x equals negative 4.
Oh,
The derivative 0 is 6.
looks like it's.
It's a 0. Happy?
Yeah.
Okay. So then what do I want to do with that?
4 and 1 below and
Okay,
above.
plug something in the over.
Okay, so what is something to the left?
Negative 5.
Something to the right?
Negative 3.
Sure. Okay, so if I plug this into my derivative, I would have 4 divided by negative 1 squared. It's still going to be positive, so I end up with a positive, yeah?
Sure.
Yeah.
And then if I plug in negative 3, I end up with 1, and it's squared, which is a positive, so it's a positive.
So increasing negative
So it's.
infinity, infinity.
No.
Mom?
It'd be
Why?
negative infinity to
Or one of
negative
that.
Oh, wait, because this. Oh.
Oh, that one was
Because
just
that's
like
an
that
undefined
because it was
value.
0.
Correct. So notice on this one, right? it's not gonna be everywhere this time. Because on my first one, 0, I can still plug in 0 and I get 0, and it's just a point. So it's increasing everywhere. However, if I plug -4 back in here, what happens?
Breaks.
Bad. The world explodes. Okay? So I'm increasing from -infinity to -4.
You get
Union -4
infinity.
to infinity.
Because it's
My
Because it's not a hole, it's an asymptote.
knowledge.
Is that the funny?
It does.
It's the dotted line.
Can you show me what the
Correct.
graph would look like?
Sure.
Yeah, I
Just
was
a
trying
second.
to.
So if because -4 is an asymptote as well, even if this went from positive to negative, it still wouldn't be a relative min or max. So no relative min or max. It's gonna be a rational graph. So circle. Yeah, they were asking what that graph would look like.
Oh, I know what.
So we would have an asymptote at -4. We're gonna have a horizontal asymptote. Sorry, at 1. Then they're both going positive, so they would both be going
Correct.
Oh, it's asking.
like that.
Wouldn't that one be
Wait.
decreasing? The one on the right wouldn't it be decreasing? Shouldn't
Oh.
it be on the bottom?
Sure. Yes. Sorry.
So wait, it never touches 4? Is that why we?
There you go.
Never touches -4.
Okay, so that's why it was like not like the first.
Why is there a horizontal asymptote?
Because my degrees are the same, which means that if I found the limit as it approaches infinity, then I would divide by my highest exponent, and then you would end up with 1 over x. So you would end up with x over x, which is 1 divided by x over x, which is also 1 plus 4 over x, which is 0. So you end up with 1 divided by 1. We have a horizontal asymptote. Sorry, what was the question?
You say whether it's increasing or decreasing as it approaches the asymptote.
Huh?
When you
How do you word it?
When I say it's increasing, I would say it's increasing from -infinity to -4 and -4 to infinity.
Do you have to say that? Oh wait. Yeah.
Is that what you were asking? Then I don't understand the question. Okay, then I don't know how to answer it. Like if it just states where is it increasing, I'm just listing an interval.
Like when it
I
says
can't include my asymptote because my asymptote is not a part of my graph.
How do you, which way do you like read it? Because if you read it from like left to right.
You have to go left to right. You have to go smallest to largest. So it has to start at -infinity and end at infinity.
One at the bottom be increasing though?
it is.
Oh, it is?
That's why I just said it's increasing.
Oh, okay, I thought you said it was decreasing, so I was confused.
No. Both of them are positive, so I labeled both as increasing. INC stands for increasing.
Yeah, I thought you said it was decreasing. Oh,
Yes.
Can you explain why there's no relative min or max again? I just don't
that's what I read there.
get it.
Because we didn't change signs. So remember that our first, bring it back in for a second. So remember that our first derivative test tells us that in order for us to have a relative min or a relative max, we have to either go from positive to negative or negative to positive. So if my f prime of x does not change signs, that means like I didn't go away. Like
Okay.
so, and like there are 2 different ways that can happen. One of them is that I have something that looks like this, where even though I level off, I continue going up. So even though this has a horizontal asymptote, or sorry, a horizontal tangent line, okay, it doesn't like, it's not a maximum because it doesn't start going down on the other side. Or in other words, it's positive on both sides, so it doesn't change sign. The other place that could happen at is if I have an asymptote on my graph, okay, again, this is like a double jeopardy as far as like, it's positive on both sides of that graph. That means that even if this was not a break in my graph, it would still not have changed sign, so it's still not a maximum or a
Okay.
minimum. However, we looked at one yesterday Where here it changes sign at 0. Okay, it goes from positive to negative at 0. However, 0 is not included in my original domain, so it can't be a relative min or maximum because it can't be 0.
Okay.
So like the one we had yesterday was like, even though I had 2 like points, the only one that was a relative min was -8 because 0 wasn't a part of my original x values that it could be.
Okay.
Does that make sense?
Yes.
Like if something is an asymptote, it can't be a min or max.
What about the local one?
If it's an asymptote, it cannot be any type of min or
Okay,
maximum.
yeah. I just know like how do you know if it's a local relative min?
So relative mins and maxes are local
they
mins
are?
and maxes. They mean the
Okay.
same thing. Like local and relative mean the same thing.
Okay.
Absolute and global also mean the same thing. If you wanted to figure out, like, if I had multiple relative maximums and I wanted to figure out which one was the absolute, then that's where we have to make that table and plug in the values to figure out which one is the biggest value.
Oh, is
But
that the
most of the-
packet you gave us? Or no? No. Just kidding.
It was what we talked about in 3.1, where we had to make the charts from our original function.
Okay.
Kind of like absolute and relative location.
Okay. Now, the other place that we see this happen, okay? We're gonna look at applications of these things, okay? So we're still using our first derivative test. We're just using it with context now. So this says the function describes the motion of a particle along a line. Find the velocity of the function. Identify when it is moving positive and negative, and identify the time that it changes direction. Very wordy. But again, remember that we tend to not struggle with the math itself. Usually y'all are okay with like the previous questions. Where we tend to start to struggle is when we have to break down what do those words up there actually mean. Okay. So let's first break down just that first part. Okay, it's describing the motion of a particle along a line. Okay, so what that means is that we have some point that's traveling back and forth. You with me?
Jolly all time.
Okay, which is different than a curve, right? So when we've been talking about relative mins and maxes, or increasing and decreasing, we've been talking about curves. So when I'm talking about a particle that's only moving left and right, we are not going to have relative mins and maxes, or increasing and decreasing, because it's only going left and right. You with me? Okay.
One.
However, alright, if I am the little particle, and the particle is moving to the right, whenever I get as far as it's gonna go, and it stops, yes, to change directions, agreed? What can I say about that point? It's not an end point, because it's still gonna continue, it's just gonna continue in the opposite direction.
It's an interval.
What's an interval?
The place where it stopped.
The place where it stopped is a point. Yeah.
From where we
But what's gonna happen at that point?
Oh, a critical number?
Possibly. Why is it a critical number?
Because it changed directions.
But why? So how do we get critical numbers?
Like, how's it turning? Is it like,
Yeah, it just stops and then goes
so
back.
it doesn't curve?
So we find critical points by setting our derivative equal to 0. Okay? So if I want to find the derivative of my position function, what do we get? Velocity. So what does it mean when I said velocity equal to 0? Yeah, it's stopped. I've stopped moving. If I have no speed, no velocity, I am no longer moving, correct?
Yes.
So by setting my velocity equal to 0, I am finding the critical points because that is the derivative. However, we are also finding where we've stopped moving, which are going to be the spots where we could change directions. Because I can't just like there's no way in the real world to change directions without first stopping in order to go the opposite direction. Does that make sense? So the only spot that we can change directions is when our velocity equals 0. Agreed? Okay, so let's find that. How do I find my velocity of my position function? Take the derivative. So what is the derivative of that? 3t squared minus 20t 40t plus 128. And then yeah, we're looking for where it changes position, or where it's changing direction. So again, that means that I have to have stopped. So I'm going to set that equal to 0. We have a quadratic. So how do we solve
I'll
that?
do the thing. Make 2 of them, but I don't know.
You could try and factor it by grouping, and this one actually does
the formula.
factor. However, if I do 3 times 128, I'm going to get a rather big number, and then I'm looking for factors that add to negative 40. So in this case, even though it factors, it's probably going to be easier to just go ahead and use our quadratic. Okay? No.
Wait, what are we doing?
40 plus or minus the square root of 160 minus 4ac all over 6.
Where do we get 160?
40 squared.
Is it b squared under the?
B squared minus 4ac.
That's one thing I'll remember.
Okay, so what is 4 times 3 times 128?
12
Hold on, I
times
got you.
128.
You can use your calculator.
That's 12 times 128. 1,536.
What?
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 Is it 846?
Oh wait.
1,536.
1,000.
Are we doing the full equation?
Oh, I forgot his zero.
I was about to say.
1600. Okay.
That's one of those things.
I got this for like 64.
There we go.
Oh, all of it?
Yeah.
I thought you just wanted the last 3.
Oh, that's just 8.
Okay. So then, what is 40 plus 8 divided by 6?
80 divided by 6.
Which is 8. Okay. And then, what is 40 minus 8 divided by 6?
4.
What?
A little
32
Right.
divided by 6.
Okay, I'm sorry.
I can't do math.
5 and 1/3?
It's gonna be a fraction. Leave it as an improper fraction.
32 of 6.
Leave it as a reduced improper fraction.
16 over 3. I just remember mixed numbers.
I'll leave them in my mouth so that they become less crunchy. Let me get soggy.
So then, what do I want to do with those numbers?
Make a number line.
So these two numbers are the spots where it's gonna do what?
Change
Change
direction.
direction.
So it changes direction at 8 seconds and 5.333 seconds. Yes? But now, in order to identify where we're moving positive or where we're moving negative, right? What are we looking for?
The signs.
Sign of what?
The derivatives near
Positive or
that.
negative.
Yeah, but of what?
Your velocity.
The
The
seconds.
velocity,
The
my
velocity.
derivative.
So you
Right? Because remember
I try so much.
that the only difference between velocities and speed was that velocity has direction, right? That's what our positives and negatives tell us. You with me? So if we're positive, that means we're moving in a positive direction, which for us means to the right. If it's negative, that means we're moving in a negative direction. If it said that like it was moving up and down, then positive would be up, negative would be down. or it's however it gets defined for the problem. So I'm still gonna set up my number line the same way.
Put up.
So, what do I want to pick that is to the left of 5.333?
Five.
In between?
7.
Sure? And after?
9.
Sure? So, if I plug in 5 into my derivative, what type of number am I going to get?
Big one. Ooh.
Wait, which ones are?
3t squared minus 40t equals 128. I just need to know if it's positive or negative. Let's do calculations either in our head or in a calculator.
It's gonna be negative.
Barely.
No.
I just need, is it negative or positive?
It's gonna be negative.
It's positive.
It is positive.
Okay? Then, if I plug in a 7, what do I get?
Negative.
It is negative. And then if I plug in 9,
Positive.
Let's do the math.
Positive.
it'll be positive.
That's pretty funny.
Okay? Which means that where is our particle moving in a positive direction or to the right?
Movable from
Negative.
No.
Oh, right, because you can't have negative time.
Correct. 0 to
16 over 3.
16 over 3. Also, 8 to, we can go forever big. So we are moving right at those two spots. Then when are we moving left?
16 over 3 to 8. Is there a relative or there's min and maxes or no?
So we couldn't call it a min or a max because again, my particle is like it's moving along a straight line, right?
Right.
What we could say though, the way that it would be worded is when is the particle the furthest away from the like starting spot?
Yeah.
Does that make sense? Yeah, like one side or the other.
Will it ask that ever?
It could, yeah.
Okay.
Usually it's gonna say when is it the furthest away.
So would that be?
That would be a maximum. So you would
So
be going
5
from
to
positive to negative. So it would be 16 over 3.
Okay. That's in the middle of 5 to 7, right?
That was our critical point that we found.
Okay.
That's right.
Awesome.
The graph is some like really so because okay, so then the t here is the x, right? Because time is along the x-axis because time is constant, and then so the distance, and this is physical. Sorry, I just got out there.
Hey, bring it back in. You might have the same question.
So then the distance, I was always taught that time goes horizontally because it's a constant. It doesn't have a zero. It never changes.
So we're talking about an independent variable. Yeah.
And then the distance would be the dependent variable. It would go back and forth. So wouldn't it be moving up and down on the graph? Like if we were to graph it.
Graph.
The-
What? All
the
right. What are you wanting to graph? Because here I'm
The
graphing
equation.
my position.
Yes, the position equation. Wouldn't it be going up and down because distance would be on the y-axis rather than on the x?
If you wanted it to be, I guess it doesn't matter. I'm talking about my. You're thinking in a very narrow frame of mind, as far as like you're wanting the distance to be represented by the y-axis. That's not always the case. We will see places, and this one doesn't specifically say it, so yes, you could write it, but a lot of times it'll say moving horizontally along the line.
Okay.
So like your function is represented by t, which is time, and s of t is just position in relationship to the starting spot. So when I say that it is -5 position, that that is -5 spots from where it started. If you want that to be to the left, it can be. If you want that to be down 5, it could also be. In this case, because it does not give you whether it's moving left or right or up and down. Whenever we create a coordinate plane, we are just deciding what those axes mean. Okay, so yes, conventionally, do we normally put position on our y-axis? Yes. Does that mean it has to be? No.
Okay.
Just like in this case, when it says positive and negative, technically, if I wanted to define moving right as negative, then moving right would be the opposite. If I wanted to define moving left as negative, I could. Just not what we conventionally do, but it's whatever the problem defines it to be. Does that make sense?
Yes.
Alright, we're gonna look at one more.
Oh, I think you forgot the
Coughing
numbers.
forces vet rachia to contract.
So true.
What do these words mean?
The trachea.
Ah, there we are.
Did you say Adricha?
Okay,
Vet.
so coughing forces the trachea to contract, which affects the velocity v of the air passing through. The velocity of the air during, there should be an R there, coughing is given by the function where K, okay, where? Okay, where K is a constant, big R is the normal radius of the trachea, and the little r is the radius during coughing. What radius will produce the maximum air velocity? And no, we did not forget the number.
Oh, okay, right.
They're not going to give us.
I know, we were missing a few letters. I thought maybe the
Is
numbers.
this like one of those
Alright, so again, what is it asking us to find?
the radius
The maximum.
The maximum, right, of the velocity, right? So what have we been using that finds maximum for us? The first
derivative rule.
Yes. Okay. So we're going to need to take the derivative of that. Okay. However, what radius, okay, is going to be the one that is changing? Little r, right? Big R is just really going to be a constant depending upon the person that it is, right? So when I am taking the derivative of v, I'm wanting to take it with respect to the radius that would be changing, which would be our little r. Agreed? Are we all okay with why I'm taking the derivative and why I'm taking it with respect to little r?
What does that mean with respect to little r? Like, what's that changing?
He's gonna put respect on
my
my
words.
It's like taking a normal
So it's going to change, like when I am using my power properties and things like that. Okay. So it changes, like right now, if I took the derivative of this, okay, if I just said dv d big R, then this would be 1, and both of these would give me zeros because I'm not taking the derivative with respect to little r. If I'm taking the respect to little r, then I'm treating these as my variables, and I'm treating big R as a constant.
It's just which one.
It's like my x variable. It's like what I'm treating as the variable that I'm having to apply the derivative to.
So we don't have numbers because we're gonna pretend the other things are
Or,
numbers.
yeah, we're gonna pretend that it's
Okay.
a constant. It's just a number. So I need to know which one am I actually treating as the variable,
Okay, which is little r.
which is little r.
Okay.
The only thing that I would probably do is I'm gonna go ahead and distribute the k and the r.
Could you have done like
All right.
the multiplication?
Are we all okay?
One
Yes,
if
you
wanted
could
to?
have done the product
Okay.
property. It's just a little bit easier to go
Right.
ahead, especially with so many variables. It's like trying to figure out which
Okay.
product property you want to use. I would probably leave it at that.
Okay.
So again, remember that I'm only taking the derivative with respect to r. And big R is not dependent upon little r. If big R was dependent upon upon little r, then I would have to do implicit differentiation. Okay? Because big R would be like our y. Here, however, it's not. Like, the normal size of your trachea is not dependent upon what it is in your cough, right? So it's just like a constant as well. So if I take the derivative of r squared, what do I get?
2k.
2k big R little r, right? Because it would be 2r to the first. Yeah? Okay? And then what is my second part going to be?
3k r2.
So that's my derivative. Are we all okay with that so far?
I really am actually.
Yeah? So then, how do I find a max or min? What's my next step?
Make it equal 0.
Set it equal to 0. Now, again, what is all of this with respect to?
R.
Which one?
Little r.
Little r. That's the only one we care about. So, what do we want to do to solve that?
Can we not just go ahead and make both of those things?
What I would, I wouldn't.
Okay, right.
I would factor out anything that we have in common.
Okay.
Which is a k and a
One.
little r. So then we're left with 2 times big R minus 3 times little r.
And then we mix
There's
it.
both of
And then we would set both of
Zero.
those equal to 0. So my first one is just going to give me r equals 0 because I would divide by k at that point. Then on my second one, okay, I would get 2 big R minus 3 little r equals 0, right? So I would subtract a 2r, divide by a negative 3, so I get 2r divided by 3.
This actually makes so much sense.
Are we okay with
I'm
that?
like mind blown right now.
Or no,
Yeah, I can't
no,
tell you. Are you being
divided by
honest?
negative positive.
What?
Right.
You're being honest.
Correct.
Actually.
Yes, it does end up being positive because I would subtract the 2r, big R, and then I would divide by a negative 3. Alright. Are we all okay up until this point?
Yeah, make the line.
Alright,
Make the line.
So then, remember, what's my next step?
Find the maximum.
By doing what?
Drawing a
Finding
number
the
line.
positives.
Drawing my number line. Okay. So here's where we have to do a little bit of thinking.
Hey,
Okay.
Right,
Hey,
it's like
yeah.
R on it.
We have to figure out where. Okay, I know 0 is just a 0. However, we have to figure out in context of 0. Okay, where is 2 big R divided by 3 going to be?
On the right.
Why?
Because your R can't be a negative radius.
It can't be negative, and it also can't be 0, right? Because then you wouldn't have one. So my R has to be positive, something. It has to be at least bigger than 0, which means even if I take 2/3 of that, it's still going to be some positive number. It could be a really, really small number, but it's still going to be a positive number. So it would be somewhere over here. Now, also thinking about my intervals. Do I need to plug in something to the left of 0?
No.
No.
Why not?
Because it's on our interval.
You can't have negatives.
Because again, I'm trying to maximize my little r, which again is a radius, so I can't have a negative value there. So I really only care about numbers that are in between 0 and 2r over 3 and bigger than 2 big R over 3. So, what would a number that's in between 2 big R over 3 be?
That's
Just R over 3.
So like 1/3 R, yeah. What would a number that is bigger than 2r over 3 be?
3R.
Which would also just be R.
R.
We're all pirates in this one. Okay? So now, again, remember that R is positive. Agreed? K is also a constant, so it's also going to be, we're assuming it's positive. So this first part is going to be positive in both of those.
Miss Bennett,
Agreed?
what's a pirate's favorite letter? You would think that, but his true love is the C.
Exactly.
Okay, so if I plug in R divided by 3 for my little r, okay, I would get 2r minus big R, which is just going to be R. And again, R has to be positive. So this would also be positive. So this is positive.
Yes.
Wait,
What?
Well, I would say.
Sure, hold on.
I don't even know what it's asking.
Okay, so again, we're trying to make our sign chart.
Yeah.
Yes? So I am plugging in my test point
Yeah.
back into my derivative.
Yeah.
I'm using my factored derivative because it makes my life a little bit easier.
Right.
So if I plug in r divided by 3 into my little r here,
Okay.
k, which is a constant, times something that's positive is going to give me a positive. So then if I plug it into my second one, again, I'm plugging it into my little r. This would be 2r minus 3 times r divided by 3. This just becomes r, 2r minus r. It's still r. We've already established that r has to be positive, so that second parentheses also has to be positive, which means my overall sign is positive.
Yes.
Okay. Now, under the same thinking, we already said that my first thing is going to be positive. But now, however, notice that this would become
Negative.
2r minus 3r, which is going to be negative 1 times a positive, right? So this would become negative. So my overall is negative.
So is that
So you know your
maximum?
So our maximum is there.
Relative max.
Yes.
You already know your-
So, because we are changing from a positive to a negative, our first derivative test tells us that we must have a maximum at that spot. So we know that the maximum air velocity happens at little r equals 2 times big R divided by 3.
I said me.
That's like the absolute
Max,
right?
It would be.
And what our
Because after that we would be decreasing. In this case it would be both.
oh
Because we don't
Right,
come
that
back
makes
up.
sense.
We don't come back up anywhere else, so it just goes down forever. So that's my only maximum.
okay.
And then negative.
Other questions?
I like